Good afternoon, all of you. Welcome to 360 interview preparation session. So today we talk about data and how we can treat the data. So in data, we are having different sources. We're going to collect the data. So data is of two types. One is primary data. And second one is secondary data. So a primary data which is does not exist with us, we're going to create this primary data by conducting surveys. And by doing some experiments, we're going to collect this data. Secondary data which is already existed with us, with a client or with a company, that is called as secondary data. Already existed data. So while we talking about data, it has a lot of noise and lot of anomalies in the data. So we have to treat that anomalies and errors in the data. So let me while we going for data pre-processing, we have to look for what are the anomalies or noise in the data. Is any typecasting is required for data? So if we want to convert the class or type of a data, let's say my data is in character, so I want to convert into numerical data. So let's say converting into integer. Okay. In another case, if date is in character, in some cases we're going to convert into date format, date or numerical. If duplicates are there in data, we're going to looking for any duplicates are there in data. If we find any duplicates, we're going to delete those duplicates. And we're going to look for any extreme values are available in data. Extremely low values or extremely high values. We have to identify, and we have to identify what these outliers can influence. So we're going to treat these outliers. There are different methods to treat these outliers. One way is 3R technique, and another one is vincerization and trimming. So in 3R, we're going to use 3R method, that is rectify, retain, and remove. We try to rectify them by using different methods, and we try to treat those outliers. Because we try to have those outliers while we are going to do analysis, we're going to consider, or else we're going to remove them. So another method is vincerization. What it will do is it's going to be replace the outlier with the second highest value. Example, I'm having a data set contains 1, 2, 3, 4, 5, 6, 7, 8, and I'm having an outlier, let's say 229. So what it will do is in vincerization, it will take second highest and going to be add 1. So 8 plus 1 equal to 9. It's going to be replaced with 9. This is one. So another method is trimming the outliers. We're going to trim them, or we're going to remove those outliers from our analysis. So the another we're going to check for, is there any missing values in the data or null values, NA values. So checking for NA values or missing values. If missing values are present, we're going to treat them. So we're going to use imputation methods to treat these missing values. And we also try to find out the whether it's having zero variance, or is there any differences in the variance from its mean. We're going to check it. If data is spread about it, it mean, then we can able to see that features is having, there is no relation between the independent variables. So here, what the question what we can able to get here is, what are the key properties of a data set? Let's say, what are the key properties or characteristics of the data set? So here, what we're going to do is we're going to apply our EDA techniques. We're going to look for what is the center of this data set. And for center, or mean, you may call it, of data set. So then we're going to do visualization. We're going to look at how the data is spread about its center axis or between two variables. So spread of the data. And we also check for the symmetric nature. Or you may say checking for skewness. If skewness equal to 0, then your data is normally distributed. Symmetrical distribution, you can say. Skewness equal to 0, it is normally distributed. So next we can check for the correlation between the independent variables. Correlation between features and also the dependent variable, let's say output. If you're going to checking the correlation between, let's say, y and x, y is being my output and x is input. So I may call this as a predictor. If I'm going to change this x by 1 unit, then there is a significant change in y. If I'm unable to identify this one, or else and keep on changing this x value, I didn't observe, or there is no change in y. So I can say that there is no correlation between y and x. Similarly, I have other variables. So if any predictor which is not having correlation between its output, it's not making any changes in the output variable, then we can able to drop this one. We can look for that one. There are no correlation, then no need to consider that variable in our analysis. And we also check for, is there any outliers in the data? Is there are any outliers? Outliers and inliers in the data. So if there are any outliers, then we're going to use this outlier treatment methods to treat those outliers. So what is an outlier and what is inlier? Inlier. So outlier is an extreme value it could be extremely high value, it could be extremely low value. So most of the cases, these values, outliers, are not the errors or else typo errors falsely enter into the data. Most of the cases, these outliers are a valid data points. So we are going to have high values, extremely high values and low values. We're going to treat them as outlier. So how we can able to identify these outliers? So there are different techniques to identify these outliers. One is, based upon the standard deviation, Z-score and standard deviation. How to identify outliers? One method is by using Z-score and sigma, standard deviation. If you talk about Z-score, we're going to look for the normal distribution curve, or standard, at least standard normal distribution curve. It's going to be our mean position. So in 1 sigma, we're going to collect 68% of the information. 2 sigma, we're going to consider nearly 95.7. 3 sigma, we're going to get nearly 97.6% of data we can able to capture. So the data beyond this 3 sigma plus or minus 3 standard deviation from its mean, we can treat them as outliers. Data beyond plus or minus 3 standard deviation is treated as outlier. So below this 3 sigma, we almost captured most of the data. Nearly 97% of data we have captured. So beyond this one, we're going to treat them as outliers. The another method is by using quartiles or box plot. Going to be used quartiles only. So if Q plus or minus 1.5 into IQR interquartile range. If an outlier going to be less than this value or greater than this value, less than, let's say, Q minus 1.5 IQR, is going to be treated as an outlier, as an extremely low value. If it is greater than Q plus 1.5 IQR, then it's going to be treated as the outlier and extremely high value. So with these methods, we can able to identify the outliers. So what is inlier? We know what is outlier now. What is inlier? So inlier lives in the data. It lives in data. Identifying inliers is very tricky part, and it's very hard to identify inliers because it might be an error in the data. So that's why those inliers are formed, but it seems to be the valid data only. So how we can identify these inliers? There are no specific methods are there for finding these inliers. So if you want to find these inliers, you have to compare with another data. You have another data, then you can compare with current data, then you can able to find these inliers. So how we can treat these missing values? What are the methods we can use to treat these missing values? So before that, how these missing values can be created? There are different variants in missing values. Let's say one variant is missing completely at random, MCAR. So for example, you are weighing players' weights by using the weighing machine. So due to some electrical problem, or else let's say the battery is not working properly, then whatever data you are recording about their weights is not exact. It is giving different values at different time. We were storing the data of player 1, player 2, player 3 and their weights. So you're getting the data differently, 70, 200 pounds, 100 pounds, and 10 pounds. It's randomly giving those values due to the fault in the machine. Then this data is missing randomly. Sometimes it's giving correct value, sometimes it's giving wrong values. So such data we used to call missing it completely at random. So another data we are having similarly missing at random, and third variant is missing not at random. So these are the variants how missing data can create. Another way is if somebody forgot to fill that data, then it's going to be a null value, missing data. So how we can treat this missing data? What methods we can use? What methods are there for treating missing values? So one is we can treat with mean or average. Second, with median. Maybe third is with standard deviation, ST, and we're going to use some imputation methods to treat this missing values. So example, you can take Canon, random forest, regression models as well, regression imputation methods. So by using these methods, these models, we can able to predict the missing value. So you decided to treat this missing value with a mean value. Is it acceptable? Let's say, is mean imputation is acceptable? If it is, why? And if not, why not? Let's say, why not or why not? So if you're going to use mean imputation methods to treat missing values, it's going to be a very bad practice in most of the cases. So for example, so I'm having a table of fitness of the people. So my data contains, let's say, 15 to 80 age of people, and their fitness I'm going to calculate. That is my parameter where I can able to find out fitness of each and every person. Let's say I'm having 15, 16, 20 years, 40 years, 60 years, and 80 years. So there is a missing value here. I want to find out. Let's say here for 80 years person, I don't know his fitness score. So I want to treat this missing value. If I decided to treat with mean, what will happen? Can I replace with mean? Yes, you can replace with mean. But what will happen here? If I'm going to take the average of these people from 15 to 80 years, okay, then what might be my average? I'll get maybe a 40 years age of that person, and I'm going to get that fitness value. So what I'm going to do, I'm going to replace that here. Then a 80 years old person going to be have this fitness? No, right? Certainly not. So here, then you are replacing with data which is less accurate and less confident about. So another example, let's say my data contains maybe a 50% of missing values. Then I decided to treat with mean. I'm going to fill all these 50 values with mean. Let's say of 30, I got a mean. The rest of from the rest of the columns, rest of the rows. So I'm going to replace all those 50% with 30, 30, 30, 30. Wherever missing value is there, I'm going to replace with 30, 30, 30. So here what will happen? So your data going to become biased. Become biased in nature. Then what will happen if your data is biased? So what is biased data? Let's say there is a movie released for Rajnikant, let's say. So in the show, the seats are occupied by all the fans of Rajni. And I'm here waiting outside to record the reviews about the movie from all these people who are watching the movie. They came out and they're going to give a review. So being all these are Rajni fans, what review I'm going to get? So they're going to giving the review in 1 to 5 star, let's say. I'm recording here. For first person, second person, and review. Then what will happen here? So being their Rajni fans, they're going to give, let's say, 4 to 5 star. 5 star, 4 star, 5 star, 4 star, 4 star, 5 star. So most of the 5 stars going to be there. Then can you able to get actual review of the movie? If in this case. So in a data set, if there are certain groups are not balanced. Let's say in a class, number of boys is not equals to number of girls. And if let's say number of girls are very high, then your data set is unbalanced and it is biased towards girls. Okay. So another example, let's say I'm conducting an interview in a college. So I know most of the people in that college, let's say by other means I know. So while selecting these reviews, what I did is I selected the people whom I know. I filtered their resumes only. Then here, what is happening? I am being biased towards the people I know, right? So I'm not picking the other people who are eligible also. So it is kind of example for biased data. There are different categories in biased data. Let's say sample bias, It also depends upon time interval. Let's say if there is a sale in Amazon, okay, they're going to launch at a certain point of time only. They're going to collect the information at a certain point of time. And then also they're going to keep the sale at a certain point of the time only. Let's say it's going to be start March 15th. Let's say 10 a.m. It's going to be end, let's say 4 p.m. in the evening. And they're going to collect the data of the purchases at a particular point of time. If data is collected at a certain point of time, there is a chance of become biased. So what is the problem with this biased data set when we're doing any analysis? So when we're going to consider this biased data set in our analysis, it do favor for certain group only. Or it's going to be predict that every group is valid. So if you're going to consider the bank data, fraudulent transactions and genuine transactions, if your data contains, less fraudulent and more genuine transactions, then you built a model, then your model going to be learn more on this one. You're having less fraudulent transactions. Then whenever you're going to predict any new data is there, then you want to predict whether the transaction is fraudulent and genuine, then you try to show that even a fraudulent transaction as a genuine. It means that your data is going to be overfit. So another bias, that is observer based selection. So I want to capture about a certain stars in the universe. Okay, so when I'm looking at the universe, the space, I have a lot of stars, a lot of galaxies and all. Of course, galaxies not visible, but by means with telescopes and all, they can able to observe. But my concentration is not about everything. I'm going to concentrate a certain patch. I don't want to consider the all other parts. Okay, based upon my observer, I'm going to create some boundary. Okay, I'm biased towards my experiment. I don't want to consider that one. So it is also called observed based biased data, because I'm going to concentrate a certain patch of the stars. So here I'm going to concentrate on it. I'm not going to consider the other stars or other spaces. So it is observer specific selection, then it is also called a biased data. So here the question is how you can able to treat or how you can able to nullify this problem. Means how to treat this bias problem. So the one method is taking random samples. The second one is oversampling. So taking the oversampling means, let's say I'm having one section of data where I'm having less records. Let's say I'm having here less fraudulent transactions, and another and that data I'm having high fraudulent transactions. So I'm going to take these less, less fraudulent transactions more, and I'm going to balance this with oversampling. Then I can able to get out of this bias problem. And third one is undersampling. So undersampling is, let's say in less fraudulent transaction, I'm having only 20. So now I'm going to, select 20, genuine transactions. Okay. So then I can able to do analysis on this one. So with this, we can able to avoid, bias problem. So whenever we're going to look at the data, we try to, understand what this data about. What are the characteristics of the data we have to identify? What is the distribution, whether it is follows normal distribution or is there any skewness? We have to identify all these things whenever we are looking at the data. So let's say there is one example. You have to generate, let's say you have to generate a report. Or you're going to compile a report about content upload. So in your data, you have seen at a certain month, a certain time, there is a peak in your data. Say people are uploading their content in the form of images, in the form of videos. So you're dealing with the image data. Then it is March. There is a peak. And how are you going to correlate this one? This is very peak in this month. Seems to be anomaly to you when compared to all other months. In March, you can see this content is being so big all other months it's looked like this one. Let's say at March, it went to its peak. And at April, and again same. So you're going to look at what factors are affected, what to having this peak in particular month, let's say in March. Maybe you're going to look for there are any events there. Let's say we have seen ice bucket challenge. Most of the people started uploading their videos and images, even in Instagram and Twitter. At certain months, it's very high. So maybe this event can trigger having this peak in your data. Okay. Or else there is a campaign conducted in March where they have to upload their images. Okay, by saying, or else by showing some symbols for world peace and all. Okay, they conducted that campaign to collect some revenue to help the pictures. Then you can able to address this peak of data. So you have to look what the external factors are caused to having this peak in the data. Sometimes data itself, if you're going to look into the data, maybe you're unable to identify what causes to have this much of peak in the data. Again, you come back and you have to identify, is there any other factors affected, what other challenge or any campaigns are there. Yeah, with outliers, if you are going to have outliers, and if you want to treat with mean, it is not correct. Raghu, I think, yes. Because if you are having outliers in your data, what will happen to mean? Let's say I'm having 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and 100. And 10 be mine. There is a missing value here. Let's say 4 is missing. So what I have to do in case of outlier, so I didn't identify this as an outlier, then I'm going to treat this missing value with this average being this outlier considered. And there is another missing value, and I'm going to treat that. So you're going to treat with the mean, where the mean is going to be influenced by outlier. Take a scale about mean. Without outliers, it's going to be stays like this. If extremely high value to move towards your right, extremely low values are there, and you try to move towards left due to outliers. So in case of outliers present in your data, then don't go with mean. Okay, so which one we can use in that case? We can use median. We can use mode, depends upon the frequency of the data. Any data is repeated, then we can able to consider more. These are also not possible, then we're going to see for the imputation methods, means model based imputation methods to treat this missing values. So what is the difference between observational data and experimental data? So this observational data will come from the observations what we're going to make came from observational data. Observation variables, and you're going to find out is there any correlation between them. Then you're going to report that it is observational data. So in experimental data, we can choose what parameters we have to capture. Experimental data parameters or variables, certain variables, what variables we have to capture. So we're going to choose our parameters and variables in experimental data. For example, so you want to calculate or else you want to score sleeping score of individuals. Let's say you want to record so let's say 1 to 10. Okay, 10 is being good sleep and 1 is very poor sleep. Sleeping score for different individuals. So what you did is you divided them into 2 groups. So first group, you did not given anything, just your identifying their sleep patterns, and you're given medicine, or else let's say you're given some wine to them for 30 days. And you have to look at whether due to this wine, is there any increase or else improvement in the sleep? Here means wine, how this wine is going to be affect the sleep patterns. Okay, so this is the experimental data. Means you're going to be choose your parameters and variables. So in data types, we are also having structured data, and unstructured data, and semi-structured. Structured data we can see, which is going to be have a designed schema, a blueprint. Schema-based data capture. Example, the transactions, your Google Pay or your Paytm, your credit card transactions. So this all data is going to be recorded TV. So it is relational database management system. What it will do whenever you do a transfer, okay, it's going to be have its schema, its parameters. P1, P2, P3, P4. So according to these parameters, the data is going to capture. That data is a structured data. And unstructured, so unstructured images, recordings, all MP3 uploads, all those data is going to come under unstructured data. It does not have any schema in it. It just stored the data as a file. And semi-structured, like example, XML and HTML. Data is in XML and